Hi guys, Murkin from OhmLab here. I wanted to give you another quick update on our progress with the Arduino core. We've implemented two ready-to-run examples for instance segmentation and pose estimation in Arduino, which you can run straight out of the box when you get your Neuro N6. We've also got a third example which showcases the ability to declare and run two different neural networks sequentially from within Arduino. Okay, so let's take a look at our first sketch here. So this is the multi-pose estimation example that you can see in our examples folder. So at the top we've got four libraries. We've got the Neuro N6 app, which is all the core functionality. We've got models.h, so that's what you need to include when you declare your neural network, as I'll show you later. Then you've got the post-processing libraries for the post-processing and overlays, then the OV5640 Arduino driver. So we've come to all the neural network stuff for now. Let's just focus on the vision pipeline. So first of all, we need to initialize the camera. So we're doing that in WVGA resolution, and you've got some mirror and flip options here which aren't selected. Then we've got three DC MIPP pipelines. So the first one is for the USB. So this takes the YUV422 output from the camera and dumps it straight out in WVGA resolution. Then we've got the neural network and the LCD pipelines, so they convert the YUV42 to RGB888, and for the LCD we've just got that dumping straight out in WVGA resolution, as that's the resolution supported by our touchscreen. Then we've got the LCD initialization, which initializes the LTDC controller on the STM32N6, and finally we're just starting both the USB and the LCD feed in continuous mode. As we come down to our loop here, all the neural network stuff's commented out, and we've just got our send frames, which sends frames over to NeuroStudio. So if we pull NeuroStudio over, as you can see, we've got the camera feed in WVGA resolution at about 30 FPS, and as you can see down here on the LCD, we've also got that displaying frames simultaneously. Okay, great. So now, as you can see, we can change the resolution. So if we go down to VGA, so we'll set NeuroStudio to VGA resolution as well, and we'll comment out the LCD for now, as this only supports one resolution. So now all we're doing is just sending frames to NeuroStudio. So let's upload that and see how that looks. So now we're in VGA resolution and we're running at about 45-46 FPS. And as you can see, the LCD screen is now blank, as we're not sending any frames to the LCD. Great, okay, so let's try running some neural networks. So in our multi-pose estimation example, let's just uncomment out all of this neural network code. So first of all, we need to declare the multi-pose estimation model and initialize the MPU. Then we need to turn on the DCMIPP pipe for the neural network. So this is very similar to the LCD pipe in that it's an RGB888 conversion, and we're initializing that with a 256 by 256 input size. That's what the size of the multi-pose estimation model expects. So let's just start the LCD feed as well, so we can see the overlays on both NeuroStudio and the LCD simultaneously. Then we initialize the post-processing, so that's a confidence threshold and an IOU threshold. So you can adjust these based on your model, tune them to whatever you like. Now in the loop function, we're first going to start a snapshot of the neural network pipe into the neural network input buffer. Now if you do need to do any pre-processing, you can then do that in place on the input buffer. However, the DCMIPP writes the exact format of pixels needed for this specific model, so we don't need to do any pre-processing. We can run inference directly on that input buffer, then perform post-processing on the output buffers, and we can draw overlays for the LCD. So this input argument here just tells the LCD controller to clear the overlay, draw the overlay, and then reload it so it gets displayed on the LCD. So when you're running multiple neural networks and you want to show overlays simultaneously, you can adjust this input argument. I'll show you that in a bit. And then of course we need to build the metadata for the overlays to send to NeuroStudio. and attach it to the next USB frame before we send the frames. Let's upload that and see pose estimation in action. Okay, so that's all uploaded now. So let's bring Neuro Studio over, and as you can see, we've got pose estimation running on Neuro Studio and on the LCD at exactly the same time. Now we are running at about 10 FPS on Neuro Studio here because the N6 is under a lot of load. It's encoding frames, drawing overlays on the LCD, and drawing overlays for Neuro Studio, and sending all the frames over USB. All this while running 3 DCMIPP pipes simultaneously. So as you can see, you can toggle the overlays on and off, so boxes, key points, bindings, and you can toggle them all on and off at the same time. You can see the inference time of 42 milliseconds, both on Neuro Studio and on the LCD below. Okay, so let's have a look at this second Arduino sketch here. So this time I'm declaring 2 different neural networks. So we've got the multi-pose estimation and the instance segmentation. So at the moment, the weights binary files for both of these models have been pre-uploaded to the Neuro N6. So I did that using our Python uploader tool, but we're going to integrate that functionality into Arduino so it will automatically upload those binary files for you. And it will also check that those binary files haven't already been uploaded, so it doesn't waste time uploading them again. Alright, so let's go through this script. So we've got our camera initialization, NPU, and our 3 DCMIPP pipes. So I've commented out the USB pipe for now, because we're not going to be using Neuro Studio for this. And we've got the LCD initialization there. And then we're just starting the LCD pipe, and we're initializing both the post-processing for these models. I'm using the same confidence and IOU thresholds for both, as these values seem to work well with these models. So down here in the loop function, we're running these neural networks sequentially. So we're first starting the capture into the multi-pose estimation input buffer, we're running inference on that, and then we're post-processing the multi-pose estimation output buffer. Now we're drawing the MPE overlay, and notice the input argument here is only reload, so it's not clearing the overlays from the instance segmentation. It's only reloading it, so it brings it forward to display on the LCD. Commented out Neuro Studio for now, and then we move on to instance segmentation. So again, we capture into the input buffer, run inference and post-process, and this time we've got the clear input argument for the LCD overlay function. So this will clear the results from the previous loop, so you don't see streaky overlays from previous inference results. Alright, so let's upload that and see how that looks. So as you can see here down on the LCD screen, you've got the results from both the instance segmentation and the pose estimation displayed simultaneously. So the loop is running pose estimation, then instance segmentation, and it's drawing both the overlays onto the same buffer and reloading it once per loop. So as you can see, I'm being outlined by instance segmentation, and my limbs and head are being tracked by pose estimation. So this is a really powerful tool for being able to see the results from multiple neural networks at the same time. Notice that I do have duplicate bounding boxes. Right now we're drawing all the overlays from both neural networks, but we will be implementing functions and input arguments where you can turn off specific overlays just like you can in Neuro Studio. We've also got duplicate inference times. However, the inference times for both of these neural networks are identical, so as you can see, it's not really changing much. So let's just give you a better view of what this looks like. See if we can pick up any other classes here. Got my phone here. There you go, cell phone. And let's see if we can pick up this bottle. There you go. So, as you can see, extremely powerful tool. At the moment, we've incorporated these 2 examples plus this simultaneous example in our examples folder in the GitHub repository. and we'll be adding all of the examples that you've seen on our social media into this examples folder, so you can run them straight out of the box, and we'll be implementing more of these cool simultaneous demos as well. Okay, so that's all for now. Thanks so much for watching, and keep an eye on our social media for more videos like this, where we'll showcase all the new features added to our Arduino core as we develop it. By the time you guys receive your boards, you'll have a fully fleshed out Arduino environment to test multiple different examples, all the capabilities of the Neuro N6, and be able to create comprehensive applications with your own custom models with a streamlined workflow. Thank you all for your support, and I'll see you in the next one.